How do you know if two things are congruent?
I'm not looking for comments.
In this lesson, you will learn to identify congruent figures by comparing their segments and angles. When we discussed translations, reflections, and rotations, we said that they were rigid transformations because no matter how we slid, mirrored, or turned the figure, it stayed the exact same size and shape as the pre-image. Congruent is another term in geometry which means having the same length, measure, or size. The symbol used when saying two segments, angles, or figures are congruent is this symbol. Looks like an equal sign with one small squiggle on the top. A common misunderstanding regarding congruent is thinking that two things with the same shape are congruent. These are both yellow lines, but they are not congruent because one is shorter than the other. These two right triangles have the same angle measurements and are the same shape, but one figure's segments are longer than the other figures, so they are not congruent. Two segments are congruent if their lengths are the same. AB is congruent to CD because they are each 3 units long. Notice how A corresponds to C and B corresponds to D. Two angles are congruent if their measurements are the same. Angle ABC is congruent to angle DEF because they both measure 45 degrees. Notice how AB corresponds to DE and BC corresponds to EF. Two figures are congruent if they are exactly the same size and shape. Notice how angle ABC corresponds to angle EFG, and they are both 80 degrees. Notice how segment DC corresponds with the length of segment HG. They are both the same length. In this lesson, you have learned to identify congruent figures by comparing their segments.
So, if we are looking at congruent, so congruent means same shape, same size, okay? As you are taking a look at this picture, right? We want to look at the sides that actually have, if we are looking at this, so turn to the front, put down please. If we are looking at this, A matches with which letter over here? A matches with R, so please put in R. B is in the same place as S. C, so fill that in, is to P, and D is Q. Now, what's nice about that is that now when we go down here, we use this notation. So AB, if we are looking at that, and the notation that we use is that it is congruent. So that's this little symbol here, and for some reason, this kind of gets jumbled here. But you should have had this symbol, congruent, means congruent to. So AB, if we are writing that, is actually going to be congruent to. And so we're going to put the same letters, RS. And it is not just without the segment. So please fill in the other three right now without saying them out loud. So BC, I should see on your paper SP. And do the last two also. Okay? Do you agree? QR, PQ. Down below it says, okay, this symbol means that the angles are congruent. So angles congruent, A we would think would be the same as up here. So A should be with R. Fill in the other three. Okay? So again, you can just look at the letters that were matched up above. So B with angle S, angle C and angle P, and D and angle Q. No, just grab a pen here and do this. I know you'd like to find more ways to here. I know. You don't have your own pencil, just let's do this. This will work. Okay? So we're just filling in those ones that match up. It says, if we look below, it says all the turtles are similar and the small ones are congruent. So when we take a look at this picture, I want you to number these as this is going to be my turtle 1, this is going to be turtle 2, and this is going to be turtle 3. It says what reflections, rotations, translations, or combinations of these would get the small turtle to be congruent to another one. So I want you to think with your shoulder partner, if I was going from 1 to 2, what kind of transformations would I have to do? And I might have to do a couple of them. From 2 to 3, what type of transformation? And from 1 to 3. So right now, I'm going to have you talking with your shoulder partner as you are looking at these. And as you look at those, kind of think with your shoulder partner, okay, if I had to look at this, what would I have to do? What type of reflections, rotations, all that kind of stuff would I have to do? So talk to your shoulder partner right now. Going 1 to 2. Okay? If I call on you or your partner, I kind of want you to tell me. If not, I want you to wait. So Grace and Elena, what do you guys think? 1 to 2. What might you have had to do? Rotation. So how much would you rotate it? Oh, do you want the head to be down? Can't rotate it 180, right? 180 is going to flip this from up here down here. Micah and Ellen, what else could you have done from 1 to 2? Turn it 90? Then the head would be up here or down here.
What's the 180?
Taylor, Micah, or Taylor and Kylie, sorry. What do you guys think? Translation. How would you, so translate it? Can we just translate 1 to get to 2? We got to reflect it as well. So someplace there had to be a reflection, like we have to reflect it, and we might want to say, reflect over like a vertical line, right? Because we don't really have a y-axis. So a vertical line, right? So we have to reflect it over some type of vertical line. And does it matter where I put that vertical line? No, not really. And then we have to translate it. I agree. Then we have to translate depending on where our reflection turned out. So reflection and a translate, okay? So now I want you to think about 2 to 3. Did you guys discuss 2 to 3 and 1 to 3? Okay, do that right now. Do 2 to 3 and Gavin and Kaden, what'd you guys have?
Reflection over the x-axis.
Over the, like this? Reflect it up?
Over the y.
Reflect over, we're going to say, I take y-axis or a vertical line, right?
We put that on the test.
No, you'll see it'll be different on the test. And then we had to translate. Okay? How about that last one? Anyone have that one that they and their partner? Lucas, what did you guys have?
You just translate it.
We're definitely just going to translate. And if we were telling to translate, if we wanted to be more specific to get from 1 to 3, we'd say translate to the right, and down. Okay? So kind of keeping those things in mind is what we're going to be looking at. So this one, what combinations of reflections, rotations, translations are going to match A to get to R, right? So A, B, C, D onto P, Q, R, S. Now, I don't like that they put this one A, B, C, D, and then they said to P, because A really matches up with R, right? And then S, and then P, and then Q. So really, if we're going to correspond, we want to do what? What does it make sense as you look at the picture? We are rotating, right? And if we kind of look at this line as almost vertical to now over here, it's almost horizontal. We should be thinking of rotating it. This is counterclockwise, and it looks like it's going to be 90 degrees. Now, notice none of these were in coordinate planes. Yours will always probably, a lot of them as we get doing this on the test and on the quiz, will look more like this, where we are looking at them in a coordinate plane. Okay? So turn to this page of your notes, if you would, please. And it says, is figure D congruent to figure B, and is figure F congruent to E? Now, before we even start, in order for it to be congruent, it has to be the same size and shape. Notice from A to C, how long is it? 2. And A to B is 3. And if I go over here, D to F is 2 and 3. So, are the two figures, do they look congruent? Yes. But what we are going to be talking about is what I'm going to ask you to do is to show me and explain how you map one onto the other. And you're going to be specific. Like those last questions in like that worksheet 5 and worksheet 4 that you had to do. So again, we're going to look at this video. It's pretty quick.
I don't have a ruler and a protractor, but I need to tell whether two figures are congruent. In this lesson, you will learn how to show two figures are congruent by using a sequence of transformations. Let's review. We know there are 3 kinds of rigid transformations that keep size and shape the same: rotations, reflections, and translations. In a reflection, size and shape stay the same, but orientation and position change. In rotations and translations, size, shape, and orientation stay the same, but position changes. Is figure D congruent to figure B? Let's investigate by first just looking at the 2 triangles. I can't get to figure D using a single translation. I can't get there by using a single reflection, nor can I get there by using a single rotation around the origin. Is figure D the image of figure B after a sequence of transformations? First, we'll try reflecting over the x-axis. Can we get to figure D from this quadrant? We'll try with a 90-degree clockwise rotation, and it doesn't fit, so this won't work. We'll try a reflection over the y-axis. Can we get to figure D using another reflection over the x-axis? Nope, that doesn't work either. We'll try again. Let's try reflecting over the y-axis and see if we can get there using a 90-degree counterclockwise rotation around the origin. That doesn't work either. We'll try a rotation first. We'll do a 90-degree counterclockwise rotation. This looks good. If we translate 4 units down, we see it fits. Since we know that both rotations and translations leave size and shape unchanged, we know that a sequence of a rotation followed by a translation will also leave size and shape.
There's other ways of doing this. Some of you could have done it a different way and still get it to work, or you might even do more than this. Like you might do 3 or 4 things. So this is the quickest one, 90-degree rotation, and we go counterclockwise, and then we tell it to translate. And you're going to be very specific when you do that, okay?
Unchanged. If size and shape stay the same, these figures are congruent. We have demonstrated congruence by showing that figure D is the image of figure B after a sequence of rigid transformations. Is figure F congruent to figure E? Looking at the 2 figures, we can see that figure F is not the image of figure B after a single translation or a single reflection, and not after a single rotation around the origin. Can we demonstrate congruence through a sequence of transformations? We'll try reflecting over the y-axis first. Then 180-degree rotation, and it's not going to fit, so this won't work. Let's try reflecting over the y-axis, and then reflecting over the x-axis, and then a 90-degree counterclockwise rotation, looking good. If we just translate 1 unit, we see that it works. Since all of these were rigid transformations,
they did 1, 2, 3, and then 4 things to get it, okay? Now, do you always have to do it? Is sometimes some people will choose a harder way to do things. And you know that about some of your classmates. They will kind of get stuck on a certain way of doing it, and they will actually make it harder than you have to as you're thinking about this. Gentlemen, are you done? Good.
None of them change the size or shape of the figure. We've demonstrated that figure F is congruent to figure E by using a sequence of transformations. We used a sequence of reflections, rotations, and translations to show congruency. Common misunderstanding is thinking that there's only one sequence of transformations that will demonstrate congruence. This sequence uses a 90-degree clockwise rotation and a 1-unit translation to the right to show congruence for the same problem that we solved using 2 reflections, a rotation, and a translation. In fact, there are multiple ways to get to the same result using different sequences of transformations. Try and see if you can think of another way to achieve this result besides the 2 ways we just showed. In this lesson, you have learned how.
So when you think of that one, if we were reflecting it twice, what else could you have done to get it down here?
You could reflect over X.
We could have done what? What's one thing that would have got it down here? A 180. So, right, it could have been similar to that one they had, where you rotated 180. That would have ended it up down here where you have then this one, right? Something like this. And then you're going to turn it and rotate it. So you could have had 2 rotations. Then you still might have to do a slide. You'd have to depend as you are looking at that. So I want you to take a look at this one, and we're trying to decide first off, are these 2 congruent? Okay? So take a look. Are the 2 triangles congruent? So here's one way where I have students kind of looking at these to decide. Is notice from C to F I go over 1, 2, 3, 4, 5, and then up 1. So that's like a 5-1 triangle. So I need to make sure from one of these 2, this one definitely doesn't look like that, but is this one, 1, 2, 3, 4, 5, 1. So I know it looks like this side is going to be congruent to this side, right? And if I'm looking here, this is 3 by 3, so this side has to be congruent here to 3 by 3, and then this last side, okay? Yes, question?
Just look at the points that they have there already.
You could, yeah, you can look at those points. But I want you to just notice sometimes on some of your homework, I'm going to give you 3 different pictures. And 2 of them are congruent and 1 of them is not. So a quick way of just looking at it is kind of looking at those type of things. So if we are looking at this one and it says, okay, write a description that's going to prove these 2 triangles are congruent. That means I need the steps for how you're getting from one to the next. Now, if I am looking at this one, what are we thinking is one way we could do it? Some of you are already seeing. Talk to your shoulder partner and see, what do you think is going to get? And then I need to know which one you're starting with, right? Are we starting, is this going to be our figure 1 or is this one going to be figure 1? Let's put this one. This is going to be number 1. This is going to be our image. So this is the pre-image. This is our starting point, and we're trying to get down here, okay? So talk to your shoulder partner. What could you do to get this one down here? I heard a lot of you say 90 degrees counterclockwise. So let's start. What do we want to name the triangle, Jacob? The first one. Name it with letters. Say it one more time. T. He's going to C to W. And we think that that is congruent. Jack Field too. So if you start at T to C to W. P, K, L. Okay? So order is important. And I heard a lot of you say 90 degrees counterclockwise rotation. So let's take a look at point T. Point T was located at -1,6. Write that down. If I am doing a counterclockwise, that means that T prime, the first time I do that, counterclockwise, right, rotation, should give me what point, Sanjay? -6, -1. Which, in our case, is P, right? So does T automatically match up to P? Yes, exactly. If we look at -9, 4, -4, 9, that would do the same thing. And same thing with K. So this one is only one thing, a 90-degree counterclockwise rotation. Now, I want you to turn, and most of you should probably, and this is the reason that we are doing H8 tomorrow, and if you have your device and you finish this, so as you take a look at this lesson, I'm going to hand back your quizzes, but take a look at, if you would please go down to question number 6, 7. Most of you should have no problems with 1 to 5. The key thing is, if you're talking about a segment, this answer must have a segment over the top of the 2 letters, right? So when you put those 2 letters, I need a segment over the top. When I look at angle number 3 and angle number 4, it says what angle? I need angle then with the letters, right? You got to tell me the 3 letters. So please look at 6 and 7. It says, if the 2 triangles are congruent, explain how you know. Write the congruent statement. Now, if I am looking at these being congruent, right, you need to tell me which angles. So you need to tell me triangle to another triangle. Does it matter if everyone kind of has the letters in a different order? If someone starts the first triangle with M and someone else starts it with L and someone else starts it with N, it doesn't matter, right? You can choose which one you start with. It's just that then your answer over here has to match in the same order. What makes 2 things congruent? What was the definition that they said? Same size, same shape. The sides need to be the same, so you need to tell me about it, because it says, explain how you know they are congruent. So the explanation is something to do with the sides and the angles, so make sure you're explaining that. Then, if you take a look at questions 8, 9, and 10 on the back. 8 and 9, most of those are pretty easy. Most of you are going to have no problem matching those up. Number 10 is a 2-step one, and we really haven't had anything like this. Because the only reflection we've done up to this point has only been over the y-axis, right, going across, or the x-axis going up and down. Now, I want you to look at this. Here's the y-axis and here's the x-axis. And if I'm trying to get from figure A to this figure B, what I might think of reflecting over this line. This line is where x equals 2. So, when you start this one, here is my hint. And when you do that reflection, I need you to draw that figure, right? So you're going to kind of draw it like this. Okay, you're going to actually kind of draw that. This is different than what we've had before. Your first step here is to reflect. We aren't going to say over the y-axis because the y-axis is way over here. We're going to tell it to reflect over x equals 2. That's the line. It's a vertical line, x equals 2. And now I even drew that one where it kind of looks, okay? So now you just have to finish with telling the translation, right? Okay? So